Hi everyone, this is Emily, and today we're reviewing Natural Science Unit 5, Forces. We'll talk about push and pull, magnetism, gravity and weight, and the effects of upthrust. Before we start, it's important to know there's two different types of forces. There's contact forces, which you need to touch the object in order to move it, and there's non-contact forces, which are invisible forces that you can't see with your eyes. Push and pull. You can push an object away from you or pull an object toward you. So balanced objects have opposite but equal forces. If you look at this first picture, you'll see that there's opposite but equal forces. So it's balanced. The table will not move. Unbalanced forces are opposite unequal forces. So there's a small force and a large force. So the table will move in this direction. Unbalanced forces can make an object start moving, speed up, slow down, change direction, or even stop. Let's take a look at these examples. The dog uses a push force to stop the ball. A pull force will pull the school bag along. A swing uses push and pull forces, where it pushes away and pulls back. A pull force will slow the dog down. And the soccer player uses a push force with his head to change the direction of the ball. So here we have an example of balanced and unbalanced forces. 300 newtons is pulling this direction, and 300 newtons of force is pulling this direction. So the object won't move. The rope will stay where it is. Below, however, there's 400 newtons pulling left and 300 newtons pulling right. So since there's an unbalanced force, the rope will move in this direction. Forces can change the shape of or even break an object. So a sponge, for example, when you apply a force or squeeze the sponge, it will change shape, but then it will return to its normal shape once you release the force. A metal can or tin can will change shape forever. So once you squish it, it will stay squished even after you remove the force. Chocolate is an object that breaks when you apply too much force. And a coin is very sturdy and doesn't change. All right, now let's move on to magnetism. Magnets are a non-contact force. They have two poles, and magnets can have a push or a pull force. Opposite poles of a magnet attract. Here we have the north pole and south pole of one magnet and the north and south pole of another magnet. As you can see, the north and the south poles attract. They pull together. In this example, the same poles of a magnet are together and they repel. They push apart. So when you put north with north, they push apart in opposite directions. That's called repel. They repel. Here's an example of repelling forces. When a north and a north are together and a south and a south, they repel. It's invisible. You cannot see it. It's a non-contact force. It's the same with this image here. This looks like it's floating, and it is because of the magnetic force. It's a south pole with a south pole. They're repelling. Mostly though, when we see magnets or we think about magnets, we think of the attraction or the pull force. So in this image here, the magnet is pulling or attracting the metal paper clips. And in this image here, the magnets are pulling or attracting the iron filings. Gravity and weight. Gravity is a non-contact, invisible pull force. Bigger objects have stronger pull toward their center than small objects. For this reason, the Earth has a stronger pull toward its center than the Moon. So the gravity of the Earth is 10, whereas the gravity of the Moon is 1.6. For example, the mass of the dog is the same on Earth and on the Moon, but its weight is greater on Earth than in the Moon. Why is that? Well, weight equals mass times gravity. Mass is the amount of matter in an object. It's measured in kilograms. Weight is a force. It's mass times gravity. And weight is measured in newtons. So the dog has a mass of 10 kilograms. Its mass stays the same on Earth and on the Moon because the amount of matter doesn't change. It's the same dog. 10 kilograms on Earth, 10 kilograms on the Moon. The dog has a weight, however, of 100 newtons on Earth and only 16 newtons on the Moon. And this is because the weight is a force, which is mass, 10 kilograms, multiplied by gravity. On Earth it's 10, and on the Moon only 1.6. So the dog weighs more on Earth than it does on the Moon because the Earth has a stronger gravity, a stronger pull. Sir Isaac Newton discovered gravity when an apple fell on his head. So as you can see, gravity pulls things down, pulls the apples down, pulls the book down, and it even pulls Sir Isaac Newton down toward the Earth. But it's invisible and we cannot see it. We just know it's there. Upthrust. So upthrust is the opposite of gravity and it wants to keep things floating or up. So upthrust is a contact force. The water or the air must touch the object in order to keep it up. It pushes objects up. So upthrust goes up. Upthrust pushes the boat up, and gravity pulls the boat down. Upthrust was discovered by Archimedes, and he discovered it when he was in the bathtub. He saw his duck floating. He got in the tub, and it moved the water outside of it, and he realized that it's because his body moved the water. So here's the tub empty with just the duck. When Archimedes got inside the tub, his body took the place of where the water used to be, and it pushed the water out onto the ground. So he realized that the water an object displaces has an upward force. It pushes things up and out over the tub. An object with a small mass and a big volume, for example, a feather, has a lot of upthrust. It takes up a lot of space, but it doesn't weigh or have a large mass. An object with a large mass and a small volume, for example, a coin, has little upthrust because it doesn't take up much space, but it weighs a lot or has a large mass. So here's an example of two objects with the exact same mass, but one of them has more upthrust because of its shape. So as you can see here, the modeling clay, when it's in the shape of a ball, sinks. However, when the modeling clay is formed into a hull, it will float. Why is that? Well, it's because when it's in the shape of a boat or the shape of a hull, it moves or displaces more water than the ball. So even though they weigh the same and have the same mass, this object has more volume because it takes up more space and moves or displaces more water. This is another example with the same concept. So a solid block of steel sinks in the water while the ship with the same mass will float because of its shape. it displaces more water than the brick. Buoyancy. Buoyancy is very similar to upthrust, and it is when an object floats on water or an object sinks in water. So if the object has an equal weight to the amount of water it is in, the amount of upthrust, the object will float. The object is buoyant. However, if the object has a larger weight or a greater weight than the water it's in, or the upthrust, the object will sink. So the 0.1 kilogram rubber duck floats because its weight is equal to upthrust, while the metal duck, the 3 kilogram metal duck, has a weight greater than the upthrust, so it sinks. All right, so we've just gone over all of these concepts about forces. If you have any questions about this concept map or anything we just talked about, take a look at pages 80 to 97 in your natural science book or on Blink Learning. Thanks for listening, and I hope this helped. I'll talk to you all soon. Bye!